We have done translation of graphs while we were doing straight lines, parabola, hyperbola, the exponential function, and we've done it profusely. And translation of graphs actually just means that we are either shifting it horizontally or vertically, or we're stretching or shrinking a certain graph. So this number 36.5 translation of graphs is actually a summary of what we did before, and it's just a small part of what we've already discussed. So I did it in the 3 columns here, and in each case I've provided a graph as well as the formula for that graphs and as well as what happened to the graph. Let us look at the first one. You will recognize it as a parabola. And again, I've used the green graph as my mother graph. So in this case, my mother graph is y equal to x squared. Just a simple x squared. So if I look at this point here, which is the point 1, 1, then we see what happens at the red graph at 1 is the point 1, 2. So it means that 1 is stretched to 2. 2 times 0 is still 0, and if I look at negative 1, then this point is minus 1, 1, but if I now stretch it, I will get to minus 1, 2. So this graph is vertically stretched, and this is my graph y equal to 2x squared. So if I make this a value in front of my x larger, then certainly I will have a graph inside here stretch vertically, or it's actually, we can either say it's stretched vertically, or we can say it is squashed horizontally, because depending on the a value, there's a value in front of y equal to ax squared. I used the simple parabola y equal to x squared to show the stretches, in this case vertical stretches. We use the symbol m here. We said m times the function f of x, so in this case my m is larger than 1. So my m also corresponds to my a in front of my x squared here, my coefficient. So this was my original f of x, and now the red one is now m times f of, and that's why it's in front there. So that is now a simple parabola. In this case, my m is y equal to m times f of x. We have an m value of 3. So my original one is my mother graph, y equal to the x, and then my shifted one is y equal to 3 times 2 to the x. And because of this coefficient, the 3 in front of that, the blue graph or purple graph here will be above this green graph all the time. And I've discussed it extensively in the corresponding videos for the exponential functions. We are still dealing with y equal to m times f of x, but in this case my m value is now a fraction. So we have a fraction here because the value is in between 0 and 1. It is a positive fraction, but it's in between 0 and 1. So what happens here with, if I again look at the value x equal to 1, then for y equal to x squared, we will have the coordinates 1, 1. But for the blue graph, we will have the coordinates 1 and a half for the y value, because we have a half times 1 square, which is equal to half. On the left hand side, I will have for the green graph, I will have negative 1, 1, and for the blue graph, I will have negative 1 plus a half. So we can see that the blue graph is now squashed vertically. It's compressed vertically. It's flatter than the original green graph. And the smaller this fraction becomes, if I have a third, it will be below that blue graph, but they will all go through the origin here. We are still considering y equal to m times f of x. So in this case, we again busy with the exponential function, just the regular one. And we notice that it goes through 0, 1 there. But now I'm multiplying by a fraction because m is in between 0 and 1. So if I now put x equal to 0 in this equation here, we get 2 to the 0, which is 1. So this value will be at x0 and y is equal to 1/3. And the 1/3 comes from the fraction, and that is just 1. And because of multiplying in front of the 2 to the x, we will get a flatter graph, so it will never intercept the green graph. It will never go above the green graph. It will stay because of this third. There we have 1 times 2 to the x, and the third is less than 1 all the time. So we can see that the green graph is above the red graph, which is now the y equal to m times f of x, where m is a fraction. We are still busy with y equal to m times f of x. In this case, my m is negative, and to make it simple, I just choose m equal to negative 1. That means the x values, if you put it in there and multiply by minus whatever I had on top here, like here 1, 1, will happen here with a negative y value. If I put a minus 1 plus 1 here, it will be minus 1 below here. And we can have many points. And remember, it touches at 0 because plus 0 and minus 0 is the same thing. So this gives me a reflection about the x-axis. So all the positive values becomes negative values and vice versa. If I start with the red graph and I multiply it by a minus, then it will become the green graph. So let's go a little further. Again, m is less than 0. And we've already discussed the green graph and the red graph. So this is my y equal to x squared. This is my y equal to minus x squared. So now I get this graph here, and we see that the m value here is minus 2. So that means y equal to minus 2x squared. That means that because of the 2 there, it is stretched vertically just now in the negative direction. It's exactly the same as when we had the one that was stretched vertically in the positive direction. It is now just reflected about the x-axis. If we now look at hyperbola, this is green one is hyperbola, which is in the second and fourth quadrant. So if I look again at that point there, which is a critical value, it's where it will meet the lines of symmetry. And this is x equal to 1, y equal to negative 1. Remember, we have the line of symmetry in this case. One of them is y equal to minus x. And if we look on that line here, if I look at this point here, that point will then be minus 1 over square root of 2 and 1 over square root of 2. If I just compare here at 1, then at 1, that point there will be the point negative 1, negative a half. Because if I put x equal to 1 in here, negative 1 here, I will get, this should be plus a half. Then I'll get plus a half for my answer, which is half of the distance from the x-axis to there is half unit, and from the x-axis to that turning point there is 1 unit. And the same on the right-hand side. If I again look at what happens here, then I see this is x is equal to 1, but y is equal to negative a half. Because if I put 1 into this equation here, I will get the answer of negative a half. So that means that this hyperbola, the blue one, is compressed vertically. So it runs slower than the green graph here. Let's look at the exponential function again. If I look at my mother graph, y equal to 2 to the x, this will be my y equal to 2 to the x, that's my regular one. And if I then reflect it about the x-axis, so all the positive y values becomes negative y values. So the red graph is y equal to minus 2 to the x. And then I enlarge this minus 1 to minus 3 in a negative direction. So the blue graph is now minus 3 times 2 to the x. If I look at the y-intercept of the red graph, that is negative 1. So the distance from the x-axis to that y-intercept is 1. But the distance from the origin to the blue graph's intercept is 3. So it is stretched vertically, but it's just stretched in the negative direction because of the minus 3 here.